Let's go through some of the basics of using UgCS ground control software for Agcopter and the X55 drone. In UgCS, mission level is kind of the top level, and what I like to do is set up different missions for each grower. And then under missions, then I set up routes. And the routes are fields, but the mission is grower level. So let's just say that if we're going to do a mission for a grower called Wheat Acres. And then under that, we're going to add a new route. We'll call this route the West Field. X55, of course, is our drone. Now, in these parameters, you need to look at the conditions that you have and your particular situation. But I'll go through some settings that I've used. The return home altitude, I leave this at 50, and that seems to work well in the zones where I'm flying. But if you had some power lines that were tall, you might want to set that higher. Initial speed of 5, it just makes for a smooth start. 120 meter max altitude. Then I always choose custom zones and aerodrome zones. This makes it so that you're not going to create routes that go in no-fly zones. Then these settings, we always need to go to Do Not Modify. And that just makes it default to the settings that are already in the drone instead of this software trying to override those. Then you get this dialog box for waypoints, but we don't actually, that's just kind of the default that comes up, but we actually make ours all in area scan mode. So you click on area scan, and then you get this dialog box with a whole bunch of settings. And these settings are super important to get right for safety and for getting good images, good weed recognition. And I'll go through those settings one by one. But first, let's start to lay out the field. And once you have this open and that selected, then it just takes a shift click to start putting in boundaries. And we'll just do it real simple. Maybe we'll do a little more accurate around in here. Something like that. And then to finish it, it's a left click to join them all together. And then that puts out your route. But we have a lot of settings to go through to get it right. So the flight speed that we like to use is 12 meters a second. You could go slower if you needed to, if the conditions warranted it, but slower just creates a lot more images, and that's a lot to process. You don't want to go faster than that, though, otherwise you're not getting enough images. Our turn type is straight. The spline type seems to create some kind of sudden movements for the drone, and that can mess with the images. So yeah, straight on that one. Then our flight height is 80 meters above ground level. 80 meters is what the lenses are set to be best at, and that's their best focus range, and so we try to follow the ground at 80 meters. And then the side distance is 67. And the side distance is the distance between these flight paths. And the images overlap in the middle a little bit here, but that 67 is ideal at 80 meters. Right now the direction is 180, so it's pointed straight down. You can change that to any direction you want. You can drag it around in a circle, or you can punch in the numbers here. Right now, this is your first waypoint, and so this is where the drone is going to start, and it's going to work its way this direction across like this and end here. So if we had a west wind, this is the direction that I would choose, because I like to fly crosswind, and I also like for efficiency to fly downwind. So crosswind and downwind is what we'd have in this scenario at 180. Now if you punch in 0, it'll turn it the other direction, and then it would start down here, and so if you had an east wind, this might work well to work your way downwind this way. Now the overshoot distance we set at 25 meters, and we slow it down a little bit to 9 meters. And now the overshoot is what's going on right here. You can see this is the edge of our field boundary, but we set the drone to fly past our field boundary, turn, and then come back in. And this just makes sure that we're getting images all the way to the edge of the field. Then we do allow partial calculation, and that smooths things out a bit. 2 meters above ground level tolerance level. That just keeps us nice in range at that 80 meters all the time above ground level. No actions at the last point. And then lastly, super important, on every one, you change the yaw. And you change the yaw to 0 towards the next waypoint. And what that does is that it makes sure that the camera is always that the drone is facing forward along the flight path, and that the cameras are as well, so that they're pointed like this. The drone turns, then they're pointed this direction, then they turn, and then they're pointed this direction. And that's the way the sensor is designed to operate. Now if you right click, you can drag around and you can get a better view of what kind of flight path you're taking. And also, it's always a good idea to check show elevation, and this gives you an idea of your flight duration, an estimate of your flight duration, and then the path that it's following along ground level. Now you can say you decided you wanted to fly this at a 45-degree angle. So right now we're at 26.5 minutes, and if we decided to change it to a 45-degree angle, it's 26:01. That didn't change it much. Sometimes it can make a big difference if you have a long and narrow field or the way things are shaped. So that's our west field. Now let's say we want to add another, let's say we want to move over here and do this field next. So a good thing to do is just to lock this field so that you won't select it by accident or anything like that. And then also you can just make it so it's not visible. And then we'll create another field, and we'll call this one East. Same, X55, same parameters, custom zones, do not modify, do not modify. Then we're going to switch over to area scan, and then we can start clicking this one out. Shift click. And left click to finish. Show elevation. So right now it's saying it's going to take 40 minutes to fly this field, but we haven't done our settings yet. So 12 meters a second, straight, 80 above ground level, 67 wide. We'll start it at 180 and see how that looks. Avoid obstacles, every point, 25 overshoot at a speed of 9, partial calculation, 2 meters above ground tolerance, no actions, and then again, change the yaw to 0 towards the next waypoint. Now you see it's showing 18 minutes to fly this field. Okay, that's a quick overview of how to manually create your fields in UgCS, but let's talk about if you've already created those outlines in Google Earth. So say you have this one that you created, South Field, and then you save that place as South Field, Grower Smith, and make sure it's a KML. So I already did it once, so and then go back over to UgCS. And then this time we add a new route under this same mission. And instead of create from scratch, we import it from a file. We search and find that file, bring it in. And these settings, we keep this as waypoint and we keep this as area scan. Choose our X55. And then it brings it in, brings that outline in and creates a route. Now, of course, we need to redo our settings again. 12 meters straight. Change this from 50 to 80. Above ground level, 67 meters wide. Start at 180. Avoid obstacles every point. 25 overshoot, 9 meters a second. Allow partial calculation. 2 meters above ground tolerance. No actions at the last point. And change the yaw to 0 towards the next waypoint. And we can go to our parameters next. Change that name to, I think we were calling that the South Field. And then I like leaving those at 50 and 5. Custom zones, make sure. And then do not modify. And then we can go over here and have it show us the elevation, and you can see that's almost an hour-long field that we're looking at. But yeah, so if you've already cataloged all your boundaries, for the most part, it's pretty easy to bring them into UgCS like we just did there.